Yeah, Alzheimer's really gets in your head.
Hey, welcome to Coffee Compiler Club. Here today to talk about everything to do with compilers and language runtimes. And I don't have any set agenda, and everyone's being recorded and show up on YouTube if I can remember to get my head wrapped around and get it up and going. Um, that's it. That's the starting spiel. Um, I have two minor things I can throw out to start with, but if somebody has an open question, we can do that.
So I had an open question that I was curious about people. What do you think about putting two things next to each other and just using the adjacency as a call? So like in a lot of languages, you have to be like function name, open parentheses, close
Yeah,
parentheses.
right.
But in a lot of them, they'll be like, look, if it's
Func
a single argument function, maybe
yeah.
you should just say function name space argument.
I
You know,
voted to do both for AA.
right. That's what I was thinking is I was looking at I've been listening to the APL Arraycast podcast,
Yeah.
and they talk a lot about the power you get from adjacency of things where you can make the parentheses go away. And it's often a lot easier to read a sentence that's just word space, word space, word.
What happens if you try to
And I was
do
like, it seems like in AA, you could almost write APL without changing the syntax because
But you don't need the
you could
hash.
just
It's
use all the
Aaron. I
Unicode
didn't see
symbols for
him.
APL, which are already there, and just define them as functions and call them with adjacency.
I don't have but it wouldn't be hard. Like AA's parser takes arbitrary, operator characters, but I'm sticking with the ASCII set only because that's all I've got handy in front of me. I could take arbitrary APL characters.
Yeah.
I
Sure.
I think I try to do like what you said, but the thing was if you do an add, how do you know if it's before or after the function call?
So I got it. I got the syntax worked out for AA. You said add, right? That's a binary operator. So you
Yeah,
have to
so
choose. I have A space B space plus place D. Well, that's time for a freaking that's let me share the Google Doc. This is like a stupid Google Doc thing. And we can send everyone loves syntax for whatever reason, because it's you're talking about this comma I just put in the Google Docs, right, Leo?
yeah, so if A is a function, how do you know if B applies to
Right.
I mean if the add applies to B or the results of the function? Because
Well,
that's why I didn't end up doing it in mine.
you for me, this has to be solved in the parser, so then it's all about precedence. And there's a version of this which says that it's going to be, A calls B plus C, and there's a version of this. That was interesting. Google Auto expanded something weird on me. And that other version of this is, A is calling B plus C like that, right? So there's like the two obvious. And I picked one. I don't remember even what I did. And I could change the picking as well.
But here, the operator is involved. But if it were three letters, A, B, and C, how do you choose how to call them?
Oh, as soon as you
Adjacency is
do,
just one more operator that has a binding affinity that's in the binding affinity
yeah,
ranking.
Hmm.
right, exactly. So in the case of like ABC, so you get the classic thing like this. There's a well-defined order that all the functional languages use, and I don't remember which one it is. It's like left associative or right associative. They have some binding order they all
Yeah.
pick, and I arranged to pick the same one.
Hmm.
For what
With
it's
the
worth,
goal,
Aaron,
people who
I
like write this coding style, which really isn't me, but there are plenty of people who do. Um,
But
that,
then again, if the arguments are single arguments, okay.
yeah,
But if there are multiple arguments, like you have
yeah,
to come up with something like Haskell to destruct any function to be uh, to be able to be called a single argument at a time with the remaining
yeah.
arguments to be
For
applied.
again for AA, I picked you only ever get one argument. If you want to have a multi-argument effect, you wrap it as a tuple, and it's the one tuple argument, and I give you some syntactic sugar to unpack it.
So here, if the A, you have to wrap it in.
Yeah,
in a
you
tuple.
wrap it and make a tuple. Now
Yeah.
it's called with the tuple B and C.
Okay.
And then the definition for A, let's so we can make that call. This is where the definition for A is defined to be a B and a C, and arrow does whatever he's going to do, right?
Mm-hmm.
Hey, Arthur.
Hello.
So
This does have the side effect that you have to choose either positional arguments or named arguments. There's no such thing as mixed.
Maybe, I'm currently doing
Well,
I
no.
guess
Well,
not the named arguments, but I like named arguments in occasions, or there are times when they're interesting.
Yeah, the only time I've ever really used the punctuationless argument thing was Ruby. And frankly, I hated it. But it was one of those things where I realized the reason people like something is because they're really used to it. And just coming as an outsider to it, like, I'm coming from the C world and Java world, and it just was weird. And like, there's no hints to my eyes, right? But I imagined, someone coming from Ruby to Java, they're like, what the fuck are these curly braces for? Like, why would I do this? And so it's like I think almost all of these things come down to what you're used to. The one thing I didn't like about Ruby from a technical perspective was how clever they had to get around the syntax. It's like it almost became like an excuse. It reminded me of the 1990 era when every C++ programmer had to prove how good they were by making everything into a frickin' operator. And just like it was a nightmare for 5 years. Like anyone you knew who knew C++ had written their
The
own
dot
set of
operator
operators.
and the arrow operator.
Just disgusting.
Smart reference counting pointers.
Or there was nothing smart back then, but yeah.
Yep. I remember that. One of the things that Hotspot went through was very early C++ compilers. Like we started with CFront and had to compile with GCC, but also other compilers. And there was a limited set of template things and operators that would reliably compile well on multiple compilers. And we just voted that as the only allowed subset that you could use. So square brackets or
Hotspot is not really C++. Hotspot is C with a few C++ extensions sprinkled in.
Right. It's at that time.
One benefit of trying to target the intersection of a bunch of different compilers is that's probably what's in developers' heads.
Well, on different platforms, they had different things, but because there was this working good subset, kind of nailed it down. Yeah. Okay. So we allowed the square bracket template operators for doing vector-like arrays, array lists, what in Java was called an array list, or in a lot of languages now called vec or vector. And mostly that was the only templates allowed. You got to have your variables defined in the middle of functions instead of alt head like you did in C. There were like 5 or 6 other things, and single inheritance, no multiple inheritance. Operator new and delete we used was basically it. All other goodnesses and lights were just verboten. So Haley will not join CCC, but he's active on Discord talking about grief he's doing and he's doing SSA conversions.
So if I have a struct in AA and I want to make that struct a callable, what is the actual thing with an underscore in it that I put in the struct?
When you say callable, what do you mean?
I mean, I can say A space B, and that will be a function call of one of the functions that exists in the struct A.
Oh, so A is a struct. Yeah, so you need if you do the space,
so like in Python, I can put into my class underscore underscore call underscore underscore.
No, there's
and now if I say class open paren some arguments close paren,
so if I have like a struct here, all you're going to get is structs require a dot notation. So A is a struct. Well, that was interesting. I wonder what that was about. The Google gave me a name I don't ever know I've seen before. And then you can say a dot field, but a space is not a function, so you cannot say a space and b as an argument.
Right. So I can say a plus b
No,
by
you
saying
cannot.
underscore plus underscore.
You can do, well, wait, oh, yes, you can. I'm sorry. Yeah, you can put underscore. Yes, you can do operators.
Or I
So
could do a
not,
at b.
so not allowed because a is struct, not function. So let me go add an operator in here. So what's your favorite operator you want? At sign? Here's an operator.
I mean, at sign's kind of special in your language, so I would probably use percent.
I think I can get away with it, but I can do this too. So then I'm going to have, to be an operator, I have to have a tuple here. Within the tuple, I can put whatever I want. And I'll field select on you. So X, Y, Z. Then I'm going to come along here and say A operand B. It has to be a unique function of the XYZ choices.
Right. So the syntax I'm proposing is basically the thing you have here.
Yeah.
Just don't put an operator there. Underscore underscore.
I don't know that I can do that in the parser unambiguously.
Like I feel like there should be some easy piece of syntax you can put right in that spot that says, this is my ability to override what adjacency means for this class being put next to something else.
It means what you're trying to say is I have a class, like normally I would do a.field, and by the way, a.field is a method call as well. So I'm not certain what you're trying to gain here, but you're suggesting that it's not syntactically ambiguous to support an empty operator. It's an empty binary operator.
An adjacency operator.
Yeah.
If this thing is followed by that thing, call this function.
Right. I trigger off of the operator syntax to go do that lookup. I would have to do it without any trigger. And so I don't know. So let me say that I don't see why it cannot work, but I'm not there yet, maybe.
Right. I feel like adjacency is just like any other operator. It just uses less ink. Except that when I'm typing this struct, I can't be like underscore space underscore, because that
No, you can't do that one.
Feels like it would mess your syntax up pretty badly.
No. So the operator lookup dude, the operator defining guy starts by saying, I only found underscores in operator characters. Oh, you must be an operator field. Okay, now that you're an operator field, I look for a final assignment of a tuple of whatever things. And if I don't see the final assignment, you're not an operator either. The parser, meanwhile, and these happen out of order. So the parser comes along and says, I found an operator, and later I will discover that you had an operator field to be loaded from or not. Like the A%B, A could be not defined here. I'm inferring it because it came from somewhere else. And the parser doesn't know. He has no clue. So he starts out by saying, must be, an operator. And so A is a struct that has an operator field. Whereas the adjacency guy, he says, oh, must be the case that the A is a function. One of them says must be a function. One of them says must be a struct with an operator. And now you're changing that to saying could be a function or could be a struct with an operator. That's the funny operator. And like I said, I don't know if I can make that unambiguous. So maybe I'll give it a big fat maybe.
And one of the questions you always want to ask is, who do you want to be able to read this?
Exactly.
And,
yeah,
and Cliff already has his answer. He knows exactly who he wants to be able to read AA.
That's a good point.
Cliff.
But
you're okay with it. Like, you love that. It's Cliff normal form.
So we can walk away from that point and get serious for a second. I really do want it to be readable. And I claim if you don't use operators and you don't do some other silly things, you can write code that looks a whole lot like C++ code.
I think what AA has going for it in this regard that Ruby may have jumped 3 sharks for, AA still has a simpler set of rules for all this stuff. So it's not instantly readable, but you don't have to read the entire book of
Right.
500 pages to understand. Like for me to decipher some of the Ruby code I was working on, I actually had to read probably 10,000 pages of documentation and code. And like, because I had to go in and see what tricky shit they were doing on the metaprogramming side for a DSL. And it's like, oh my goodness. Like, so just the number of layers of indirection were, they
That
could
makes
be infinite.
that makes me feel better about liking C. C plus plus is not that great, but I like it.
I mean, C is portable assembly. There's a value to that. Assembly is relatively small.
Cliff, the other day I saw an article about Swift compile time being slow because it has to infer things. Like I didn't actually read it, but I saw the title.
Compile time being slow because somebody's inferring something. Yes.
So
Yeah.
specifically, it was the bidirectional Hindlay-Milner that Chris implemented in Swift that they claim slowed it down.
Oh, I
It was
see.
not
My
actually.
understanding that claim was incorrect.
Yeah,
So
yeah.
it's not the bidirectional typing, but the combination of all of the features like overloading and subtyping.
Right. Yeah,
Yeah,
about to
with
say,
8 definitions for plus, it's impossible to generate a good error for like adding a string in. Just there's so many definitions for plus.
why is it hard to
Yeah.
make a good error message for that? Seems straightforward.
Well, because
No,
the
in
hardest thing in a compiler is good error messages. So I mean,
There's
I
that.
believe Shaw just because I know how hard it is.
Yeah, the Hindley-Milner can be quite fast. It has a bad asymptotic time, but only if you write code that you're trying to hurt yourself with, right? The code that people write does not hit the asymptotic bad time in Hindley-Milner. Hindley-Milner implementations can be very fast. There's nothing special about them.
Yeah, it should be linear. So if you
If
I will
you're
use
if
that you
you're
should
not going crazy, it should
if
be
you
linear.
yeah
There
if you
are
have
things you can find on the interwebs where people go crazy. Here, this will cause you to blow up. Well, it will because it's asymptotically big. Okay, fine.
so as long as you discover definitions one after the other, then the Hindley-Milner will be linear of the size of the program. The problem becomes if you have something like F needs B needs C, D, or the order is mixed. So you have to jump. You have to discover all of its dependencies in order to resolve the symbol. That is the only way you can slow Hindley-Milner.
Interesting.
So
Because, but I view it maybe as a different way now because I've been dealing with Hindley-Milner for a while, but maybe that's the same thing. For me, it's if you have it only happens when you get let polymorphism. You let something equal something in something, and then you get a bunch of uses of the let value. Every time you use the polymorphic value, you in the standard Hindley-Milner algorithm, you clone the existing type,
yeah.
and then with fresh type variables so that it can be polymorphically made to fit in the current context.
Yeah, that's definitely slows
If you
down.
stack those, well, then you go exponential because you get whatever. And of course, stacking them is one of these things where it's like completely
Yeah,
crazy to go.
that's correct. That's correct because you have to know which combinations, which polymorphic types have to be resolved. That slows the types to dramatically the resolution.
So once I've expressed it that way and pulled away from the out of the AST algorithm, I just have a basically standard graph algorithm on types now in the AA type resolution. But you can clone types and that will go exponential on you. I have removed I have a caching that removes one of the big O cloning places, but not all of them. So I think the AA version is asymptotically better than the standard one, but I don't think it's down from, I don't know that it's down from exponential.
Another possible combination is that since you have a structural type system that can interfere badly with the polymorphic types. If you have structure with polymorphic types inside them, that maybe because I haven't dug deep.
Okay, as far as I know, there's no conflict here.
Mm-hmm.
The structural typing and polymorphic, for me, the structural typing is you've added a name that you want to honor. That just becomes a field in the Hindlay-Milner that must match.
Yeah.
Such things quickly force, and so the timing, the performance becomes better because there's no polymorphic choices. You must be a person or a cat or a dog or whatever. It's not a duck typing anymore.
Okay, but the type you are selecting is itself polymorphic. So
I'm saying if you've told me that I have to be a cat and I have a polymorphic function that has to match up with the cat somehow, very quickly I'm only cats, and then I don't have any more choices. And one of the places where I would get a doubling, it goes exponential, goes away because immediately it's solved for cat and I'm done. I don't have a cat, of a dog, of a person, of a house, of a car.
But that is the case when you designated what the type should be, or
this is where
you have it. So if you haven't designated what the type should be, it's structural. It has to find at the cow side what you are calling that fits into the shape of the type.
What I'm saying is the exponential comes when I have a variant shape and a variant shape. I have two variant shapes. Suddenly I have to check all four combinations.
Yeah.
Right. And then you get another 4 with this other 4, and now you have to get 8.
It's exponential. Yeah.
Yeah. Okay. So as soon as I said this shape, whatever key-like shape it is, has to be matched exactly, then this guy becomes this shape without any searching. In linear time, I make this shape, it's done. Now I have just this funny shape that I said you have to be a cat, dog, mouse, whatever you will have to be structurally. And then I go on further matching with that fixed shape. So it removes one of your exponential points.
Yeah. Okay.
Okay. Cool. So I'm saying it's faster. It's asymptotically quicker if you tell me I must be a thing. Fine.
Okay.
Any more on that one before? Jim has a giant comment. I'm gonna read it, but it probably should go in the docs as a question. Jim is asking a question. Oh, indentation is syntactically meaningful in Python. And using logical code blocks, not expression parsing. Yeah. Oh, and then, okay, Haskell white space is meaningful in some context. So this is your spacing question. Okay, so Haskell goes to our original comment, which way to parse. He says Haskell is parsing the first one. I'm going to write ask. Haskell chooses this one instead of the other one. For the watchers of Coffee Compiler Club, Jim's generally in the other side of the world and has very bad audio connections, which is why I'm reading it out loud. And then there's a white space. Oh, I'm not counting the white space language. Yes, there's an esoteric language called white space. It's like brain fuck. It's there to mess with your head. No. Fine. All right.
Okay, just so you know, having worked with Cliff's code, Cliff hates white space.
This is not true.
Oh, that's a joke. That's a joke.
White space, but this is not true.
That was a joke because of the white space language. Sorry.
I am inclined to dislike large amounts of open vertical space. And I do have my spacing very particular. Learned long time ago. Now I call it Clifford normal form.
I will say, as I've started using smarter and smarter IDEs, I've been more forgiving of the single character thing, because I can be like, what the heck is this? And then I right click it and jump to definition. Yeah. And there can be a block comment explaining what it is at that point, where you're just like,
but that's good enough.
IN is the inode, and here's the structure of the inode, and here's everything that's going on here, but I'm going to have to type this 80 billion times, so I'm just going to call it IN.
There you go. That's
which is actually better than internal _ node everywhere.
See?
You know, that same smart IDE would have typed it for you a billion times, and you wouldn't have had the billion right clicks, though.
No, but you had the billion right clicks in the IDE to go make it pick one of its bad choices. Or at least all the IDEs I've used will give me the wrong choices repeatedly. Except for Emacs, which is
Yes.
pretty good.
Right. You've definitely raised the cost of encountering the code for the first time, but you've lowered the cost of working in the code, which is.
I think it's right. It's lowering the cost of working in the code. The first time reader has to figure out what you meant by inode or in. The 10th time reader who's trying to maintain and edit and work with the code sees in a million billion times and doesn't want to fill his screen. Or I don't want to fill my screen with inode or whatever longish name. That's not too bad. But I've certainly seen people who want long names.
If inode is a long name, then we're in trouble.
So I said, I know it's not too bad. But like I said, I've also seen many, many longer names and typed a million times over, and you just can't find the meat for the fluff.
So how about something in the middle? You choose a name, how should be designated when you want the full name, and the IDE will just expand it. So when you know what it is, you just don't expand
it only
the
works
name.
if your IDE and my IDE know how to do the same things.
So it's
And Emacs doesn't.
Does anyone remember when I typed in main in Clang?
When you did what in Clang?
In my IDE, I typed in main. Do you guys remember what it gave me as possible outputs?
Oh God! Oh my God! It gave you some.
Okay, Cliff remembers.
Yeah, I remember it was a horrific thing. Like, what the hell was going on there?
Yeah, I'm glad I'm running in the IDE. Let's just say that.
Yeah. All right, fine. Yeah. This is we have an IntelliJ. I've got nodes because I'm writing nodes for an IR, and I want to type node, and I have the class node. And if I type node, I would like him to say as my first choice, it's the class node perfectly spelled. But his first choice is usually like something with node in the middle and other things on either side. And his first choice is often things in other libraries that I've never ever used in this entire project's lifetime. Most of it actually projects I've never used in my
so the problem is in the weighting of the function. You have to account for the recency.
Grep, you would get the correct answer. But you used AI, and so you got a stupid answer. And why the fuck didn't you just start with grep? Fine. It just pisses me off every time I do. I'm sitting here in IntelliJ and I want to say, add node. And so I type ADD, and he's got adds thousands of wrong node. And it says, add additional something, Apache org commons, blah, blah, blah node. And I'm like, I've never used Apache org commons. Why? I use add node, it's right next to you. How can I not get to add node?
I don't do
go to
this.
the keyboard, grab the mouse, and force it to go to add node. And that's like already 3 seconds of rage and 3 seconds to go find the right buttons to click, as opposed to an instant, in there now.
I think you're missing the point that this is a great opportunity for sponsored content in order to fund your IDE.
Yes, me and Prime go after the same issues. Just what the hell? I guess.
Did you mean add node, Apache add node, or have you had your break today?
Oh, the moment the suggestion starts to include some kind of ads, then no.
All right. What else? Somebody was talking about.
I was just like wondering, when you guys have long names, is that like usually when you're trying to access a global variable or some kind of class member? Because sometimes I don't do this too often, but if I have a long name and I'm using it like several dozen times, I'll give it a short name and make it a reference. But most of the time when it's a local variable, I try to give it like a 1-word name. And if it's a class member, I try to give it like a word or two. And then if it's like neither of those, I'll give it like a long name.
So here I am busy writing a register allocator. And I have a graph coloring register allocator. And I don't want to write graph coloring register allocator because it's really a register allocator. And then there may be many implementations, but this one's going to be graph coloring. So there's a register allocator class, which is already too long for me. So it's reg alloc. It's long enough to be well unique. Inside there, I need to build an interference graph. I also need to build live ranges. And I don't want to write build interference graph or build live ranges, even though the fucking IE completes it, because I don't want to read it 1,000 times over. So at some point I start shortening these things. I guess those are the head of the classes get long, and that's okay. But I want to write a live range, and I'm going to write, this one is hundreds and hundreds of times live range. And it will run off the length of my lines, and it will hide the facts of what's going on and everything else if I have this giant thing. So I need an abbreviation for live range for all the reasons that we talked about already. It's just too much.
Yeah, same for me. I keep my I try to keep my variable names like really short, and I don't mind going for abbreviations. Like for instance, I have this array that keeps track of it's an array, and the nth element in it contains the last instruction at which the virtual register at position n was assigned, and then I could call this array last assigned virtual register, which is silly. So I just abbreviated VLA or something, which is confusing if you're in C, but yeah. And I have a bunch of other things
But
I try not. Yeah, I have a comment there, of course. The thing is, for instance, I try not to some things are hard to abbreviate, like assignment. That's a bit hard to abbreviate with 3 letters, so I don't do it. Intervals, I don't know, also sometimes difficult, but things like symbol, yeah, very easy. Intermediate representation things, I always prefix with IR, and I sometimes I just fall back to single letter or 2-letter variables, and then I just deal with it. Honestly, all the comments I have documenting the behavior of for instance the register allocator, they help so much that yeah, I don't mind. And honestly, I also think it's very important to keep the vertical space not run off of the monitor, because if I can't even parse the loop structure and all the match statements and stuff, then once I have to scroll, I always forget what my register allocator is doing. So I feel like there's such a huge value in keeping it.
Right. There's a loop. It's doing something complicated and subtle. I want it all on the screen. And then
because the thing you're trying to defend is not your length of your text file, it's your working memory.
Yeah. Yes. I'm defending.
It would be silly to take something like World Wide Web that's just 3 syllables and abbreviate it as WWW that's now 6 syllables and uses twice as much working memory.
Except it's faster and easier to say World Wide Web than WWW.
But some of my working memory is visual, and the 3 dubs in a row, that's a visual hook.
Yeah.
Very quick, very easy to spot.
Also, we can view it some kind of a trade-off with the context. So the fact that you abbreviated and all of the things, so in order to be short and compact, this is the trade-off, because you have to be inside that context. So when you allow that context in your memory, so everything is named short and tidy, you figure out.
All right, I kind of want to move away from talking about
abbreviations.
Everyone's personal favorite way to write code.
So, okay, maybe we should talk about compilers. I don't know.
We'll just acknowledge that notation is a tool of thought and go back to compilers.
Yes. Somebody was on Discord this morning talking about this would be great on CCC, but they aren't going to show up on CCC. And that was SIMD-ops. Finding and applying SIMD-ops, automatically applying SIMD-ops.
Oh,
Matt's here. He can fill in.
Maybe. Did you pile in on the SIMD conversation, Matt? I thought there were some papers came from you this morning recently, but I scrolling through back. Oh, here we go. No, long names are cool and growing a language.
So I feel like there's 2 very different approaches of, do I want to detect that I'm doing 4 additions and do them all with one SIMD-op, versus have I detected that the thing I'm actually doing is some big array math thing in which it would actually be worth moving to the GPU and coming back?
Oh, I've never
And
done
I've
that
seen
one.
plenty of compilers that are like, I'm going to detect when to use the SIMD ops, and no compilers that are like, I'm going to detect when it's worth actually getting a GPU involved.
Could.
Well, technically, we used to have a guy show up all the time from Futark.
Oh, Futark. Yeah, right.
Name is slipping my mind.
Yeah, trolls. Something.
Yes, yes.
Yes.
So, and that's exactly what his research project is doing, is using the GPU for
Oh, I thought he was doing affine functions in Hindlay-Milner so he could do range bounds intelligently.
I also like this post by Geoff Langdale, who is known for SIMD JSON, because he points out that there are many SIMD operations that are not just a dump for loop running over millions of elements of data, but there are also SIMD operations which are very complicated shuffles, permutations, maybe affine operations, and those are actually the operations that often make those string algorithms fast. And these are kind of underappreciated in programming languages, because most of the time when you hear about programming language adding an API for SIMD programming, they will only target dump for loop running over a million of numbers, but very rarely permutations or shuffles.
Don't you think this could be because like the first class in this taxonomy is just easier to deal with? Because like the example is given.
Deal with. Yeah, that's it.
Also, I grew up in the era where big supercomputers were cool and wildly exciting and were solving new world problems. And so I got a strong, hard education in how to vectorize big ass for loops, because particle simulations are going to make nuclear bombs and dams and cars safer. I guess they weren't going to make nuclear bombs safer, but we had to know how to do big ass simulations, weather. So now that that's kind of settled and solved, we get all the weather we really want. But there's these other problems that weren't, they were around, but yeah, never stared at until, man, it's time to stare at them maybe. So is Futhark actually doing the GPU thing? Because that's an easy thing to hook into the compiler. There's the runtime test. Is it big? And some definition of very big. And then you just make a function call instead of emitting the for loop. And then separately, you have to oh God, how do I shuffle the data over? And the cost of big is so big so that I can afford to shuffle the data and blah, blah, blah.
Yeah, and the other challenge that was being discussed this morning on the chat was, it's just not that easy. It's not like a simple peephole to say, oh, look, this for loop could be turned into, I can move this stuff to a GPU.
See, one issue that I ran into is I could never get OpenCL working on Linux.
That's another issue.
I think cost models kind of suck. I mean, that's kind of what Cameron said, in that it's not just a peephole, because you have to reason about the data movement back and forth. You have to be able to know how much data are you going to deal with, and is it going to be profitable to run the computation on the GPU. And if you don't know that, then you cannot really optimize this very well.
It's all about the profit metric here. There's a correctness too, but I think the correctness is easy. It's about the profit.
Yeah, my assumption is that H2O did SIMD out the wazoo, but never moved anything to a GPU. But I don't actually know if that's true.
Yeah.
Honestly, I don't know if
we just pure Java, so we let C2 do the SIMD.
And the trade-offs are really weird. There is this trade-off in the GPUs that is the trade-off between instruction level parallelism and register usage, and which is occupancy. Because you may actually make a very huge kernel and it looks great that occupancy is going to be very, very high, but it may actually have worse instruction level parallelism.
But this is NVIDIA's problem, not mine.
Well, but if you're compiling for GPUs, then NVIDIA is kind of an important target.
Then I have this problem. Right. But if I'm handing it off to the GPU, it's not my problem.
Yeah, the fact that GPUs don't really have an assembly to target still shocks me.
No, I mean, that is your problem if you are making a compiler for a GPU and you have to decide whether you want to fuse the kernels or not. That is your optimization. That is still not done by the driver compiler.
But it's a lot harder to how to detect that you can represent some of the operations. Then the obvious ones that like additions and etc. Okay, but how about that you can represent the code in a way that can be SIMD-ized?
I think the it looks SIMD-izable is a relatively straightforward test.
So what would be?
And the size question is relatively straightforward. If you can claim it's SIMD-izable, you can ask the size question fairly easily.
Okay, cool. So you have to formalize the concept of a step inside the iterator or something.
Yeah,
And
I
that's
actually think if you're just thinking of SIMD as in conversion of a for loop to vectors, I think that's like the most trivial part of compiler
okay.
optimization.
What would be the more harder?
Data communication between the for loops, because usually you are going to have more than one.
Yeah.
That's what usually is called kernels in the GPU, and you have to send some data in and some data out. And the way you arrange those for loops in a different order may have a dramatic impact on performance. So it's all the glue between the numerical computation that may end up mattering more rather than the number crunching itself. And
so you have to.
Is this a similar problem to picking the right stride for a matrix multiply?
No, it's you have a pile of loops one after another that the user wrote. And then if I'm writing this in Java land, I'll just take each loop as it stands and try to do something and let it go. If I'm writing the loops via a streaming API, then I can reorganize the loops however I like in the streaming API. And now you have this exciting question, because sometimes fusing and sometimes passing them along, sometimes breaking them up all makes a huge difference. You go to a GPU, that's really got to be their bread and butter.
And it may even make sense to have some kernels done on the GPU and then final reduction of the smaller data on the CPU. And it just runs faster because the final reduction may have some tricky divergent branches inside it that has to decide some edge cases.
Yeah. Like H2O was really optimizing big ass for loops. And then we had a reduction, but it was an x86 doing, log tree reductions was pretty quick. But we were not trying to do, I want to say, SIMD for parsing with the single exception of the hand-rolled CSV parser. But that was the hand-rolled guy. No, we lost a picture of pretty baby. Wait. Fine.
I think the compiler choosing whether or not to move computation to the GPU feels a bit like exceeding its responsibilities. I think it's a bit too much. I think like it would be nice to have the compiler be able to like either create a SIMD version or a like GPU kernel, but I think the user should pick it because exactly of the like lack of cost model, like data transfer, and also maybe you have like this sounds more like an HPC runtime like thing than what the compiler should do.
I heard this argument 40 years ago about the register keyword and 20 years ago about the inline keyword.
We are talking about here, can we come up with some concept that can be represented easily by the compiler to be discovered that something can be executed on the GPU?
There is an argument that says at our current technology point, the user needs to pick which way it goes. As we nail down more and more what we want to do and how we're doing it, will become more and more obvious what that decision is. And then there'll come a time when a compiler can do the same obvious decision, but they'll be screaming from people who the decision wasn't obvious and they wanted it a different way. And then comes the keyword that says, put it on the GPU or don't put it on the GPU. And then after that settled out and the compilers got even smarter and the GPU rolled onto the x86 finally in a decent way, I don't know, x86, whatever. We'll all be like, why the hell do we need a keyword here?
Well, the model doesn't go with, monolithic Linux very well to, pick and choose a GPU target on the fly among, the monolithic.
Oh, no, you don't pick which target. You only get the one that's on your machine. So it's a JIT thing.
I'm just saying, like, eventually it all goes to like containerization and it looks like what's his face wins, not Linus, where you get a mock kernel design where pipelines are respectively matched to their hardware and their tasks.
Yeah, maybe. Yeah. Yeah, that right. I think we're a long ways off from that one yet, but maybe it's coming. It would be if there was a way to usefully describe ahead of time the kind of resources that would be useful and the size and order of magnitude. And then, you could start making ahead of time decisions about what to do with things. But I think hand in hand with that one is a better cost model in general for a lot of things.
All of our laptops are turning into the Amigas again with customized graphics, customized audio, customized, executive functions. Now we got neural accelerators, etc. This is the architecture that lost to the PC coming back.
Yeah, okay.
I for one welcome our new AI overlords.
You just say that, so
I haven't used AI for anything useful except writing funny poems on birthday cards.
but they are getting on point. So there's no denying that.
I've seen the most reasonable comment I've seen is from Levo saying, well, you use it in replacement of Google to look up coding APIs. Don't expect the code to be correct or valid or anything, but it'll set you in the right direction. It'll find all the little odds and ends and nitpicky things, and then, oh yeah, okay, this makes sense.
So
Maybe.
how about an AI system that is directly hooked to the compiler in order to give you the perfect suggestion
I
about
I will let you define and design that. All right,
Cool.
Leo, you raised your hand. Just to say something.
Oh, that was just me trying to find out if there's more than one emoji, and I had no idea that I raised my hand.
There you go. The
I
answer
wanted to do
is
some kind of
there's at
laughing
least
one.
one.
That wasn't the plain default one.
I know I've seen smiles come by, so there's at least two. Fine. All right, SIMD and GPUs. We got any more? Or we're gonna declare victory on that one.
next topic.
Oh, Leo found a third emoji. Okay, fine. And Shaw's got one as well. All right, are we done with the emojis now? No.
Yes, I will cease the emojis.
Yes, I don't care.
I can't
It's this
even
little
figure
tiny
out how to do emojis.
board. It's the ones where I couldn't get Zoom to stop, where suddenly Cameron's face becomes full of balloons that are streaming by as a victory thing. Yeah, I don't know what you did, but yeah, there it is. And how do I get that turned off on my side? I don't care if you have it on your side. Yeah, Rotten Tomatoes there. No, Sean, it's not working. You don't qualify. You're no good.
Think the balloons, I think actually might be. Do you have a Macintosh?
No, I do not. Oh, he has a Mac.
Okay.
Oh, I see.
Okay, because I was
Hey,
gonna
I've
say I
got a
thought
Mac
someone
too.
told me
What's
it was
the-
actually the Mac, not
I suspect it's not. Two. There's the balloons. Oh, okay. So
Wait,
Aaron got
Yeah,
balloons.
That's weird.
that's a Mac OS feature that adds that stuff in.
Yes.
It's
Yeah,
not even part of the Zoom
I don't see it.
client.
I'm
It
on
is
my
literally part
on
of
a
the
phone.
OS.
That's
I
so
don't see
bad.
it.
You don't want to see it. It's very distracting and it doesn't help. Like having a serious conversation and suddenly balloons go floating by. It's like, stop it.
Yeah,
I
sometimes
love it when I'm interviewing people and they trigger that.
Sometimes it's
I'm
There's
sure
two
judges
types
love
of
that
way
when
to
lawyers have
register
balloons.
allocation. Okay, why are there balloons? I'm talking about
I'm going to have to
registrar.
like put a stop to you here, Sean.
That's
Wait, was this Gene? So another friend of ours would put his head down to think. Like I'd say something, he'd say, "Oh, let me think about this," and a big thumbs down would come over his head. Like, no, it was not appropriate. It had nothing to do with nothing. Stop it. All right, it's not the compilers either.
I made some progress. I can share some things. Actually, just a short update. So I started porting my original my first version of my registry allocator, which used this C1 thing, this paper from 2008
I'm
or
busy
9.
writing a register allocator even today. But carry on.
Sorry?
I am busy writing a register allocator today, this week, and all week, really.
That's nice. Yeah, me too. So yeah, basically after Ian's presentation, I decided to rewrite my register allocator to his paper's version, and I've been making some progress. And
Which papers?
I could the one he presented on CCC, his register allocator, and he had a paper that he published on Archive.
I'm sorry, who's he? I missed the
Ian.
Oh,
Ian
oh,
Rogers.
Ian. Yeah, that one. Oh, that looked like a good one. Yeah, I'm curious. Okay. Yeah.
So one thing that just like there were just some things that like surprised me or that I didn't realize during the CCC, but only afterwards, like how the things that are live in or out or whatever are actually instructions themselves, not any virtual registers as I had in my IR. So like little differences like that because
Is
I
this
didn't.
the new, when was that year of that paper? I got a 2020 paper from him.
Yes, 2020, I think.
Okay, I'll throw the link in. Someone can find a better link too. I just got Arvik's. Sorry, go ahead.
But yeah, basically, the desire seemed to be to just remove side IRs, remove like data structures that store intervals, like avoid memory bloat, and just like use the information that is already encoded in the intermediate, as like in the instructions, which is interesting. And my main concern was like finding ways to like extract some data parallelism out of it because I need a very fast implementation. And I did spot some like opportunities. So far, I kind of like I'm halfway through. So there was this live at the same time test, which he was talking about, and these future active and active sets. So like these things are working, but there's also other things in the paper like register coalescing and allocation heuristics and things that I haven't like been able to get these things correctly yet. But I actually think it's definitely quite hackable. So far, I think it's a really just like a neat thing. You know, it's not overly complicated, and I'm able to keep my like so far my register allocation performance for like somewhat simple code, not too many basic blocks, uh, and yeah, like somewhat simple control flow graph. Um, yeah, like right now it's actually faster than what I had before. So yeah, and don't use much SIMD primitives or anything, but yeah, like I can see that you can like for instance, maybe if you can constrain the number of instructions you want to have in a basic block, then you can make the instruction indices smaller, pack them together into a big SIMD like register, and then start forming like wide checks and things like that. There's like probably 7, 8, 9 like opportunities in the pseudocode in the paper where I actually think you can do lots of SIMD stuff. So that's what I'm gonna be doing this month, and then probably providing an update. Like, but yeah, it's exciting. I'm pretty happy about it.
Cool.
It's crazy how long it took me to understand like the things that were discussed in the CCC. It's crazy. I feel like my comprehension speed is a lot slower than I expected. Like I think it's just because many of these things are new to me, and I don't have so much of a background in the optimization part of the compiler. So yeah, but cool stuff.
Good. Yeah, there's a lot of learning stuff that I've kind of interned, and I don't know what other people don't know. So I have trouble talking stuff
I love
out
when
too
I'm
fast
working
for
on
you.
something and a conversation suddenly clicks that I had like a year and a half earlier, and I'm like, oh, that's what they said.
There you go.
I think also like something that's not to underestimate, but like very, very useful, which is like later the analysis that shows, I think later in the paper, he did mention like how large these basic blocks are on average and how many there are per method and how many registers there are allocated per method. This is very, very useful because it allows me to like think of a concept like think of a theoretical happy path and optimize my implementation for like the 99th percentile.
Yeah.
And the thing is, without a large code, like a large corpus that I analyze beforehand, I don't have this information. So having it written down in this paper is very, very useful.
The
Yeah.
average basic block length that C2 sees is 5 instructions, one of which
Crazy.
is typically a branch.
How do we
Yeah.
know that?
Because I did that test 20 years ago, but on a very large code base, even 20 years ago. Now I haven't repeated it, so it could be stale, but I don't think Java's gotten any change its shape very much. Also, when I
No,
say
but I'd be fascinated to know if like a Scala code base had the same behavior as a Java code
yeah,
base or a Kotlin
but
code
I was
base.
already seeing other people's languages at that time, not just Java's, and they changed a little bit. The usual story is I had to do so many safety checks that, after 95% of safety checks thrown away, you still had safety checks. And so the blocks were short because of safety checks. They were all highly predictable, so they performed well, but I couldn't necessarily move things past the safety check because if it failed, you had to have the state as if the world was at the moment of the check. So yeah, blocks were.
By the way, I put an excerpt in the archive in the Google Docs. So basically, like the big corpus was 693,000 methods of this Android code, and 4.8 basic blocks per method, and then 7.4 instructions on average per basic block. So a bit more than.
What is this for Java?
This is for yeah, I think yes, Java, Android, open source project stuff.
Okay.
Yeah,
that seems reasonable.
I put it in like this. Put it in the docs.
Yeah, and so maybe things have gotten a little better, or maybe the Android version doesn't end up with so many checks for whatever reason. It's all good. That's a bigger corpus than I looked at, but it's I mean, I looked at something that was probably 10 times smaller, but still quite large.
Can also depend on how you model some of these checks. For example, whether for implicit null check, do you model it as explicit branch or it modeled implicitly?
I called those the end of a basic block, but in the code, you would just have a load that was going to fault or not. But I declared it the end of a block.
Yeah, depending how you model this in the IR, your blocks might get larger or smaller.
Oh, I see what you're saying. Yeah, that's true. I know people who've done it the other way, and then they would get bigger blocks. Yes. But they would have exits in the middle of the block where a faulting null check would be legal. Yeah. I just declared that 2 basic blocks. So fine. So register allocation, let's see, I'm doing a graph coloring, not Ian's, but that's an interesting hack. I'm doing graph coloring on a weird ass chip that's got a RISC-V and a strange, weird, bizarre embedded device that's meant to do GPU-like math things.
Do you happen to know the name of this device? Or is
well,
it
I don't know that
no?
I can say the name of it yet. I don't remember what the
rules
are. So
right.
We've talked about it before. As Derek's here, you talked about it first. Derek's chip.
Yeah. We can talk about it.
So I don't have a name per se, but the RISC piece that drives is a classic. It's a RISC-V, but it's the small one, 15 registers. And the thing it drives is a gang of 8, and the gang has dedicated multiply accumulate instruction in registers and dedicated matrix multiply instructions and registers, and some dedicated input output path registers and network channels, and you're supposed to drive it, and then some crazy high throughput rates possible on the thing, and it has enough flexibility that you can use a register allocator. I don't know. We're gonna find out. I'm not there yet, but I'm getting closer. Anyhow, I was just having fun. You said register allocator. I was like, it's been a long time since I've written a register allocator, and it is kind of fun. So I'm having a fun time writing a register allocator. Graph calling register allocator. No, fine.
Also, it sounds like a chip where if you're doing too much work on the scheduler, you're probably doing it wrong.
Yeah. There's going to be some funny balances between having it on the bonus gang of 8 or having it on the RISC.
I learned that when I took the high performance computing class at Georgia Tech.
Yeah.
Which they had the students moved over into their own cluster on specific hours that was separated from all the real research.
Yeah.
Which I didn't understand until I tried to do stuff, and the whole cluster is just crawling. And it turns out because there's always one of the students in the class running their high performance computing thing on the scheduler node and never actually deployed into the cluster.
Yes. Somebody screws something up all the time. And they don't find out till later. That was one of the joys of H2O. I knew that was a flaw. And so it was peer-to-peer. It always distributed everything. You couldn't blow that one. There are plenty of things you could screw up, but not that one.
No, I definitely had days that was that HPC cluster being driven like you're trying to drive your car using the motor that moves the seat.
Yeah, right, exactly. Yeah. That's a good analogy. Fine. All right. What else can we talk about here? Graph calling allocators, and they're doing, finding live ranges and finding interference graphs and live in-out sets and those kind of things. Classic stuff. Well, and we can also, declare victory. I have stuff to do. There's your thing with almost 700,000 methods. That's pretty good. That's pretty big. All right.
Pretty nice.
I'm looking for a topic where I'm going to call it because I got stuff to do in my life. I have an artist friend here, and we're doing art for Burning Man, and he's.
Well, I have one thing, but it's not very long.
I don't care.
I was writing a new interpreter for my MiniVM because I've been doing just compilers for it previously, and
Yeah.
I'm going back to the interpreted method. And so I did like a bunch of switch statements on dynamic types and didn't do any optimizations, 600 milliseconds. Then rewrote it to do a ton of optimizations, 590 milliseconds.
You're doing it
That's
wrong.
I love C. But on GCC, right? GCC went from 800 milliseconds to 230. So GCC is just went from slower than Clang to like knowing what I'm talking about. So and Clang just assumes the wrong thing most of the time. So I just have to profile it and do PGO, and then it's like, oh yeah, I know what you mean. 250 milliseconds. So Clang just assumes the wrong thing sometimes, and I'm fighting with it. I have to like put in a bunch of unlikelies and likelies, and it's just a nightmare. No, Clang, the case where we call exit 1 is not likely. I'm going to tell you this right now, Clang.
That one Clang should pick up?
It should, yes. I agree that it really should. However, it doesn't.
Gotcha.
That's
definitely one
confusing.
of the. Sorry, I just a minor comment.
Oh yeah, you can go ahead, but I was just going to say that's confusing, and this is all switch cases.
I went from switch cases to a big jump table that's inlined. So I basically take the address of a label and inline that into my bytecode. Like I compile my bytecode to bytecode, but instead of opcodes, it's just jump to this address to run the opcode. It's 8 bytes per opcode now instead of
call threaded code in Forth.
Yeah, threaded code. Exactly. It's exactly threaded code interpreting. But like I still haven't done the getting rid of dynamic type stuff yet. So I need to get rid of dynamic types better. And I have a whole system for it. It's just annoying to implement. But oh god, Clang just does not understand. And I write good code for Clang. I got one that was 400 milliseconds on Clang, and GCC took about 2 seconds for it. I don't know what their connection with each other is.
What?
It really is. Yeah, like Clang was not having a good day that day. I think it was because
But you said GCC was slower. Why?
Yeah, for one implementation, GCC is like 50% slower. For another, Clang is like twice as slow.
Yeah.
And I can't pick one. My solution was just write both files in the repo, like have both files in the repo. If def GCC GNU C, right? If def GNU C, do this, include this file. If def Clang, do this file. Else, use a good compiler. It was the error message I wrote. So it's
you have 2 different versions.
Yes, I have 2 completely different versions depending on whether you're compiling on GCC and Clang, and this is how I got it fast on both originally. I'm trying to remove this.
And is this all like with -02 or 03 or whatever?
The flags I was using were I can get them. It was 03 FLTO FGCE SM LAS.
Don't read them out loud.
Yeah, I turned on I looked in the GCC manual for not enabled at any optimization level and turned on all those too. And it got a little faster.
But those may not actually help, or they may be incorrect.
Pointer
I was going to say, some of
analysis.
those are like divide by 0 is no longer safe.
No, I didn't do any fast math or any NAN stuff. I just did global code analysis and then like pointer analysis are the 2 that it doesn't do at its maximum level, but they take ages to compile. It takes the compile time from like 10 seconds to like 25 for the whole program. So it's not bad. It's just sometimes the user will ask to recompile the program during a running program, and oops, don't do that. Is my answer to that. Like, don't swap it out
Get a
during the
faster
middle of it.
compiler, dude.
The
I'm
compile time question
trying.
I always trip over is what is the linker doing for 3 seconds?
Too
Taking a
much.
nap, and it's actually half of the time is the linker. So
Yeah, too much.
Like 5 seconds for like 20 C files. Oh, we gotta link them now. Okay, 5 more seconds.
Yeah, it's doing too
Sure,
much.
I have 2 questions and 1 comment.
Yes.
Like first, the comment, like when the opcode is the address itself, that's called specifically direct threading. So like
it's
yeah.
direct threading, but it's like sometimes I swap out opcodes like dynamically. I'm like, hey, you've been called with an int like 8 times, like an int 32. Just pretend you're the int 32 version and trap if you're not. Like go back and undo this change if you're not the int 32 version. Kind of like specialization in Python or like a reasonable strategy in any other language.
I see.
Yeah.
I have
Yeah,
fun
so
with this similar things.
Yeah, I also am planning on once you've called like a basic block enough time, like once you've done a basic block enough times, just to start versioning it. I do this in the just-in-time compiler, but the interpreter could also benefit from this.
Cool.
Um,
Yeah, so I had 2 questions. First, is this open? Like, can people like
yes,
the GitHub repository? You
MiniVM. I will. It's MiniVM. I will get my repo.
Yeah, because I think like might be interesting. Some people might get nerd sniped by this.
Where is the document? I missed when the document was.
Well, throw it in the doc and ask your second question.
Someone pasted into the document. Yeah.
So my second question was like, how can so since you're doing the threading, like, what would the compiler even be able to screw up? I mean, there shouldn't be any like are your opcodes very complicated or something? But there shouldn't be any inlining, right?
There is an opcode. There are opcodes for all sorts of things because it generally we're above cache line length of instructions. So just doesn't matter, just add all the opcodes. I will basically the instructions are complicated and I have a method to make them simpler. I just haven't yet. And GCC does a good job and Clang doesn't. That's all I was trying to say was that, they do good jobs on different things. So there's still a lot of room to improve just by like, I don't know, doing what GCC and Clang does. But that would take forever. I don't know.
Okay, so your opcodes are like a bit more complex, like some of them.
Like my opcodes can take any form of arguments. Like if you can do add on a F32 and an F64 together, you can add an I8 and an F64. I have I8, I16, 64, 32, and then F32 and F64 as my number types, because I couldn't pick one. And I just let the user at the command line be like, hey, I want all my numbers to be F64s today. Thank you.
You got tags on your numbers.
I don't, because basic block versioning. I just say, hey, the basic block is where the tags live. And anytime you actually need a type check, it type checks. But it doesn't do this if you've done it like a bunch of different basic blocks. So if you have a function that like takes an int or a string or a bunch, like it has 8 arguments and you pass literally every possible combination to it, it'll give up after like 5 different compiles unless you call it a lot. So basically it's log 2 of the number of compiles is the number of versions you have, or the number of calls. So it means that like generally you're not getting bad performance from really dynamic code compared to like other interpreters, but for static-ish typed code that feels statically typed, it's fast and it's a Lua VM, so it does all the weird closure stuff and multiple values, and I don't like it, but I wish those are the 2 features I wish were gone. Mutable closures that kind of sometimes capture, and like multiple values that are on the stack and you can't really put them in registers because ouch, because there could be up to 250 some of them. Right. So yeah, that's kind of what MiniVM was dreading implementing. I was dreading implementing with it, and I finally got it implemented and slowed everything down. And then I'm like, I need a strategy for this. Haven't come up with one yet though.
Okay.
Also, I am waiting for Negate. You know Negate, Yasser, to get around here and start fixing. He's slowly fixing TB, the backend for the JIT. But luckily I wrote my own TB backend that's just get the TB code and compile it to C, and then call GCC on that, which is incredibly slow. but it works as a stand-in for now. So, yeah,
Yeah.
it's
Okay.
good enough for now. Yeah, I don't know. I give him a progress update on that. He's working on a new API too, which is exciting because it's going to be less bad
Yeah, I
than having
saw
to like
that.
set and unset.
Interesting.
Why
Yeah.
is it slow? Are you talking about compiling? I mean,
I'm
generating
compiling every single instruction to its own. Every basic block in the program gets an external system call to GCC. You have to start up GCC, run the linker, call DL open on the output of it. It is slow because I wasn't writing it to be fast. I called GCC on every single basic block individually with every possible type combination. Yes.
I thought you were talking about TBC's backend and
No. TB's C backend doesn't have to do that. That's just how I'm using it right now. I'm expecting the compile times to be under a millisecond, and they're like 10 to 20 milliseconds. So it's again not the correct performance characteristics. So that's why I'm writing the interpreter to get reasonable performance characteristics that are profilable for different strategies.
Yeah. Okay.
Makes sense. Should make sense.
You're dying. Yeah.
Yeah.
Well, I wish Yasha were here, but yeah, I'm interested to see when he gets his thing going. That's.
I still never had a GCC or a client give me good code with profile guided optimizations. Like I was surprised when it helped you. Do you know how much speed you got with it?
You said like a big speed up. You had like 4x numbers. Oh, we lost Shaw. All right, Shaw, you're muted.
Sorry about that. I was my wife was asking me questions about she's going to trip. Anyway, yeah. Well, could you repeat whatever someone said if it was a question?
Yeah, I was just saying that I never got good results from profile guided optimizations on both Clang and GCC.
Well, it only gives you good results if the base compiler did a bad job. It's not going to get new optimizations. It's just going to be like, oh yeah, this is unlikely, but I thought it was likely before. So if O3 gives you good optimizations, PGO won't. But if O3 is like not that great, PGO might help.
Okay, because in my case, I just had a giant function and it just didn't do a good job with both with it and without it.
It's variable, honestly. Sometimes it works. You have to run it on a representative test too, and like a big one ish.
Let me offer a different suggestion. Try breaking up your giant function.
Yes.
And see if you don't get better code out of not basically you wrote it inline, but outline pieces and see if you get better code out.
Yeah, isn't that name to not be mentioned? Doesn't he say you should never have functions longer than one line or something?
Yeah. Who is that?
That'll be real hard in Python when you need 2 lines for a function. Oof.
No, there is definitely a scale that many optimizers are best at, and they're best at what was reasonable, good-looking code in the 90s, 80s. If you write a giant 5,000 line function, you will probably die the register allocator spilling death.
Processors are best at what people have made fast in the past. What people have made fast in the past are what processors are best at. It's like Intel is optimized for C code, and C code is optimized for Intel, and nobody else can have it because the two are married.
Yep.
So since we're on that topic, how fast should a compiler be to compile code? What would
3 million in a second?
I've gotten 5 million in a second.
Chuck and a woodchuck could chuck wood.
The answer is faster than my last one. Otherwise,
there you go. Always faster.
Yeah, I've gotten 5 million functions a second, but
empirically, a compiler needs to be fast enough that you're not tempted to alt tab over to your browser.
Yes.
Okay, that's there are two sides of this. So how big of a project should a compiler? So if it's a Chromium, which is a millions of lines of code, what do you expect to wait for such a project?
Oh, most of them are written in bad languages that have compilers that are incredibly slow, so therefore I expect to wait several minutes. However, if I was writing it was millions of lines of C, I wouldn't want to work on it at all. And if it was millions of lines of assembly, well, good luck getting me to even look at that.
Whereas if you're C2 taking Java bytecodes at the millions of Java bytecodes, it's pretty quick.
Yeah.
So would you support the statement that the C2 stood the test of time for the large code bases it compiles?
Well, no one's writing JVM bytecodes.
So
but if you had a fast conversion to JVM bytecodes, C2 is not going to add a whole lot more to get x86 out of it.
This wasn't fair because the Java C converts them to bytecode.
Java C is so slow.
Java C barely optimizes that. Like doesn't it even not do?
No, it didn't. Yeah,
does it do constant inlining?
And
they took the optimizations out. It used to try to do optimizations,
and it wasn't helping. And C2 was doing a much better and much faster job of it. And it confused people who accidentally had optimizations baked in that were cross class file. And then they mix and match class files and did or didn't get their optimization because it crossed a class file. So they just took it out.
So a modern compiler should at least support 1,000,000 lines per second.
It's like, how long are you waiting? A lot of what goes off with C2 is that it's jitting and it's just in timing and it only compiles things as you hit them. So if you never hit 900,000 of your million lines, you don't ever compile them. So, why do you care?
C2 is kind of in the background. You really don't see the code it compiles.
It runs parallel in the background. Also, you don't see it. You have to interact with deal. Yeah, that's a different.
It's a different beast. So I'm asking for a compiler that compiles from source.
Yeah. So when your person is waiting as a developer, and I go edit my code, and I want it to run, I want to test my project, and I want it to debug and blah blah blah, then I want that cycle time. If the cycle time gets below like a 10th second, I kind of quit caring. If it's more than like 2 seconds, I start to drift in my head. And if it's more than a minute, it's like, yeah, switch to the browser, go get a coffee. You're doomed now. And these studies have been around. Actually, people have done these studies. And the answer is really below 10 second, no one cares. Above 2 seconds, there's a definite cutoff where you care a lot. And between the 10th and 2, there's a strong delay versus your focus. Like you could hold your brain frozen in focus. I fixed this bug. All the things that make this bug possible to understand and view are ready to go. The editor debugger pops back up right where it was. I step through, I see the bug fixed, hit continue, the bug's gone, I'm off to the next bug. I can hold that 2 seconds fairly well.
This interactivity a developer wants from
and there's Shaw saying there's a wall at 2 to 3 seconds. Yeah, post a couple seconds, you start to drift. And you lose things, and then you have to stop. And what was I doing? Why was this here? Step, step, step. Oh, wait, now I remember I'm trying to get this is that, and that is this, and it worked or didn't, or whatever's going on. So there's definitely this, wall at a couple seconds. So if your compiler is slower than that, that's bad.
I think that's a lot of why Python is such a dominant language, is that the interpreter and REPL just gives you the ability to explore in a way that
you get it.
It'd be very hard to do in Java or C++ or even
but they are not. Python is not a winner in compile times, at least yet. So
it is. The compiler for Python is wonderful. It's 2 bytecode, is incredibly fast, and there's no step after that. If you had like a C2 for Python, it would just be incredibly fast. Like
I offered to build one several times to the Python community years ago, but they wanted their interpreter. They were not.
There's a JIT in 3.13.
Sorry.
Come on, go ahead.
There's a project called PyPy.
Yes.
PyPy.
It's a Python compiler written in Python. Is that not supposed to be essentially C2, but for Python?
They had a big discussion about the things they have to change of the Python spec to get fast compile times out. And the Python spec people were not willing to make those changes. And changes are really modest. They were not willing to change them because they don't change them. It's actually a bitch to compile Python fast as the legit spec.
Yeah.
Most people will never hit those issues.
The PEP 744 in this, a basic JIT compiler is added to Python 3.13. They're actually like, oops, we made a mistake. We've got to fix it.
I was trying to say, what now? They said they couldn't have it? I mean, Python compilers have been around a long time.
No, to C Python, plain C Python is getting a JIT. Like they added a whole framework for writing one, and then they're writing one in actual, like everybody has it C Python.
Okay.
It's there's doing the baseline JIT first, but they've been doing significant optimizations since about 3.10. It's like most of the programs run twice as fast because they wrote a better interpreter. And now they're like, no, we need a JIT. And they're like, wait, the JIT API is bad. And like from what I've seen, the PyPy people are like, well, I
Yes.
wonder why this is.
Yes. Like I said, I tried and I got told, not interested in a big capitals, not interested. And I walked away. So, okay.
They're removing the GIL. The GIL is optional now in programs like the global interpreter lock. They've just made it optional. They've just removed everything that makes it necessary. It's just slower if you don't have it. I'm like, guys, what?
Fine. Okay, fine. So maybe there's sanity coming after 20, 30 years. I don't know. Maybe.
What do you use Python for? I know what a few people use for it, but what do you in specific do, Shaw?
Well, at my job, I do a lot of Python because we one of our targets of our compiler is Python. But also in my like personal work, I just use it as like the slow language that we're trying to like show people no interpreters can be fast. You're used to slow interpreters. They can be. It's like the benchmark against that you will always win. Like PyPy's interpreter is like 4 or 5 times slower than C Python at this point. Just because the JIT is all they care about. Their interpreter is really bad.
Right.
Yeah. Yeah.
There's the whole AI thing, PyTorch. Some large fraction of people use Python to drive their model building.
I use Lua for that mostly.
It's definitely though, PyTorch and Python is a large community.
Oh yeah. Yes. Transformers itself is like huge. Like the Transformers library for Python. It also takes 2 seconds to start up because they have that much code in there. But yeah.
Fine.
I mean, like I have a GPT-2 implementation that I've just written in like JavaScript. It's just JavaScript, and it's actually not slower than like different things. Like it's like V8 doesn't do a bad job of it. It's like, oh yeah, these are F32s now. Oh yeah, we can vectorize. Oh yeah, it just does a bunch of things really quickly, and it's scarily fast. Like JavaScript is not the language you should be writing the kernel of an LLM in, but I did. But no acceleration, none of that. Just no imports. Just write a bunch of matrix functions. Okay, we're good.
Interesting. Well,
yeah.
So your conclusion is Python is a good language for calling C.
Python is a great language for calling C. In fact, some of the best Python out there can compile to C, like with MyPyC and Cython 3. That's just, you type your Python and, oh, now it's C code. Yeah.
That's the running joke in the compiler community. How do you make Python, how do you compile Python fast? Well, you call C.
Yes.
Fine.
There is a tool called MyPyC which takes typed Python and is like, hey, I compile this to a C module. I will find it. Here it is. I should really find the document again, but my email.
Somebody get it in the Google Docs too. I think I've seen this before.
Yeah, MyPyC, they're getting more features. And it's just Python, but you have to type it a certain way. Most MyPy code that's like all the way typed is also MyPyC. I don't know. It's pretty good.
Okay. Yeah, but these are all the same names that have been around for a decade or more. So maybe, Python core community is changing their minds about allowing JITting and compilation. There's hope for Python yet.
Well, the Python core community has stopped being Python people and started being AI people and also some random simulation people.
Somebody came along and said, we have money. We want to take over your governing board.
We'll give you money if you make our code like 5% faster. We'll give you like $1 billion.
Right.
But I too often hear that somebody has a compiler for Python and it's well, we support this part of Python.
There are a bunch of compiler projects for Python because it's an obvious target, and the core community, maybe they're changing their tune now.
But they don't support all of Python. Most of them support some subset of Python. So it's Python, but it's not. So
The
3.13
PyPy webpage homepage has an interesting discussion of the key things they needed changed to make reasonable getting progress out of Python. And there weren't, like I said, they weren't very egregious. You had to be really bizarrely, weirdly in bed with some evil things to get run over by these, to hit these issues. It's one of those things that
I'd be interested to go through them one week and
we should. I'd have to go drag it
really
up.
understand like what is the thing that is causing
Right.
blockage here.
Right. But I remember those that they weren't very significant in the big picture. The big picture. Some Python programs would break, but not very many. And it's the kind of things that the JVM went through when it did the JNI transition, 20, 25 years ago. There had been a loosey-goosey notion of what JNI meant, and people played fast and loose with the register allocator and like IO buffers that they wanted the OS to write to, and they also wanted to be in the Java heap. And eventually, too many that broke too often, and then Java got sort of hardcore about the JNI wall between Java and native code. And then a bunch of folks broke or rewrote to match the new JNI spec, and suddenly it all got better. And the whole problem went away. Everyone just forgets about it. You call out to native code in Java, it just works. It works well. It works, does what you need. You come back. There's no performance penalty on the Java side, and you have full access to native code. You just had to have a little bit more handshake. And once you force that handshake, geez, all these issues went away, and you could make Java go fast and have your native code. But I think Python people should have jumped on that boat a long time ago. Maybe they are now. Fine. All right, I was frustrated back then. It would have been fun. I was looking forward to it at one point. I can make Python go fast.
Hey Cliff, it was excuse me. Was there anything different that you were thinking should be changed besides what's on the PyPy homepage list? Excuse me.
I don't recall now. I don't think so. This is like like I had enough wins with C2 and Java that I knew it could handle a lot of funny things and make them go fast if you weren't doing funny games and go fast. So things on the website were like the GIL turns into locking, turns into who has ownership of native memory buffers. I got my giant data array that I'm doing my LLVM math on all in a C kernel. Is the GC on Python caring about it? Reference counting and lifetimes, having a hard lifetime for, I want to say like file handles would do the ref count and go to 0 and then free, but they had other rules. And they were really looking to mostly get to scoped depth for like closing file handles at a reasonable time, like C++ destructors. But they didn't. They were using the reference counting. And you could have reference counts go long. But also you could go to the place of, we'll do a whole kind of optimizations on reference counting. And I think I was going to be able to get a C2-like approach that would have done similar lifetime, or at least if you were willing to loosen the lifetime in a semantically loose way, like say, it's not at the point the ref count goes to 0, which I then have to track religiously through the compiler, which I can't always do because of escapes. If instead it's, here's the obvious point where the count must go to 0, but instead of saying it's at the point where it goes to 0, it's within the lexical scope of where it goes to 0. Then that one I could have done. I don't know. So there's a couple things. I think the PyPy page had some good numbers, but I don't have anything now, Bill. I wish I did. That's why I'm sorting to see if I can come up with my head. Now you're gonna make me go look at PyPy. Why
I'm
is
curious
PyPy
why.
not the
How
default
how
Python?
can anyone tell the difference when that is freed in Python?
Somebody would say something about they're at the limit of the total count of file handles. They got one back and they could allocate a new one. You're at 65,535 file handles.
Yeah.
Right.
Yep,
So
yep,
that's what I'm saying. It's just like stupid corner cases. Like, no, you got 65,000 file handles open. You're dead already. You've made a mistake already.
Well, I've definitely run into file handle leaks in Python.
Yes, but see, the difference with the leak is you're going to run out and you're going to die because you're out. It's not the case that I'm exactly going to have 65,536 minus 1 and go plus or minus 1 right at that edge forever and expect it to work. If I'm leaking pretty quickly, you're out and you're done. And it's just like death. And you quit, right? If you're not leaking, you run forever. If you are leaking, you are definitely going to die. And plus or minus 1 changes where you die a tiny amount. As opposed to, I'm willing to run with 1 free file handle available to me indefinitely while freeing and reclaiming it perfectly. Where people have a conversation, I have to go find the PyPy page that has it here to get my head wrapped around about what it is you could or couldn't do. So I don't remember. Sorry, Bill. This is like a good discussion for another CCC. What is it about Python that the PyPy people thought should be changed?
Was it Max that we need to get in here for that one?
Max was doing something with Python compilation too. You're right. Bill, what are you doing? Are you doing something with Python or PyPy? We lost Bill. All right, lost Bill. Darn it. I thought he was doing something with PyPy at some point, but I don't know. Here is a very old update on Python, PyPy. Here is a newer blog archive. It's still not very new. And it won't link to it, so there's some breakage. I think I am wasting time here. Let me try again. PyPy blog moved. Yes. Go to the moved page again. No, I can't go to the moved page. Okay. PyPy.org blog, which is fine, but now why? Somewhere in here, his recent post, I'm at the correct website, somewhere on this website, and it's a big one, is why you are or are not the thing. They had some list of changes they had to do, or they thought were appropriate and were preventing reasonable optimization. I guess another one that Java went through was the original memory model was intended, the pre-Java 5 memory model, the under 5 one, was intended to allow all compiler optimizations, but they blew the spec and they denied them all instead of allowing them all. And Bill Pugh found out that and was able to show that you could not do most sensible compiler optimizations, but the intent was to allow them and give you a well-defined memory model. So the memory model spec changed to allow optimizations, but it went through a Java language spec change to make that happen. But the goal then at Java at that time was Java can be fast, as opposed to Python, which goal was we are compatible until we're not for 2 versus 3, but we're still slow. We went to 3. Fine, stop. All right, I never understood. All right, I'm going to declare done here. Unless somebody has another topic, I'm going to declare done.
I mean, if there's one thing C++ has taught me, it's backward compatibility is the feature that.
It's a feature or a curse?
I mean, it's both. Like, it is the boat anchor around their neck that makes it hard for them to have nice things. And also, it enables people to bet on that language for projects that are going to last decades.
Yeah. Or
if I had to start a project that I knew was going to last decades today.
I don't think anybody really knows a project's going to last decades.
Are you going to bet on Zig? Like, I'm worried about what Zig's going to be in a decade.
No,
I'm not that worried that C++ is going to be meaningfully different than it is now.
Yeah, right. Hey, Bill, did you ever work on PyPy? I said something and his mute's on. He was off.
Speak. Oh, sorry. Yes, I was inverted. No, I haven't. Worked on PyPy. You're confusing me with someone else now.
I was thinking you had some connection to the Python.
Somebody else did. Yeah, surely, but not me. Yeah.
All right. Thanks.
Anyway, I'm curious what art you're doing, but I think you'd probably rather do it than talk about it.
What, me?
So, yeah, for Burning Man, what the.
Oh, we're making I'm going to call it a whole face, a photo op face, whole face. A big sheet of plywood with face holes cut out, and the other side shows it's Speed Racer, Trixie Speed Racer,
Okay.
Jim Monkey, and a race car.
Okay.
There's a theme for our camp, and we're at the Department of Mutant Vehicles, so we have a race car theme, mechanic theme running around the camp. So I'm adding some art to add to the camp. And
okay.
we got our favorite artist friend, Lisa's known forever and a day. And he paints us like landscapes occasionally. It's really nice. I don't have any in the room here, but I have several in the house. He does a fabulous job with lighting. It's just unbelievable how good his lighting is on the pictures he makes. So people walking through translucent ocean water and playing at the beach, or desert during the day where the sunlight's intense. But these are all hand painted things. It's just they work out really well. Anyhow, he's taking a look at it and he's scoping it. And we have a painted white sheet of blank plywood and a plan on how to stand it up at Burning Man. And and that's one of the things running around. Other projects, the fire department came by and said we had to cut back all of our brushes that had grown up in the last 2 years too close to the house. So we have an enormous brush pile cut down, and I had to learn how to sharpen a chainsaw, and I got poison oak on my legs because of this. My mom's going into hospice. What else do you want to know? And I got 4 projects in my life that are coding, one of which is writing a register allocator for a weird, bizarre, the cat's attacking me. Ow, stop that. And one of them's getting Cameron's XDC running, and one of them's the simple C of Nodes tutorial, and one of them's AA. So I got too much going on in my life right now. Talking to the cat, we're having a conversation about the rules and rights of the cat to bite me. Okay. All right, done. Okay, I think I'm going to call it. And if you want to ask anything about any projects, go ask next week.
Okay.
Bye-bye.
Okay, see you.